So we're going to start out with the one labeled Quiz 7. That's 11-15. So this is the algebra one, combining the like terms. Most people did pretty well on number 1. 8x plus 13x, what's that going to give us? 21x, yes. When we add or subtract numbers, there's two things. One is we must start out with the same name. Both of those are x, so we're good to go there. And then when we add or subtract, we combine counts. 8 and 31 make 21, and we keep the same name, so it stays x. Now, number 2 is where we started to struggle a bit. So let's take a look at number 2. We have 8x to the third plus 3x squared minus 12x. And we're going to add to that 4x to the third, so we put that under the 8x to the third, minus x squared plus 6x. And we are adding here. Now, one thing that might help, this negative x squared, make that into a negative 1x squared, and it's a little bit easier to understand. Now, we are adding here. I wasn't mean enough to make you guys subtract. Negative 12 plus 6. Negative 12 plus 6 is what? So at negative 12, positive 6, we'll end up at negative 6. So negative 6x. So then here we got 3x squared and negative 1x squared. Positive 2, and it's still x squared. Very good. And 8x to the third and 4x to the third. 12x to the third. So it's just a matter of lining them up and adding them. I see a lot of you on your quizzes did something like this. Where you just kind of drew a link. You connected the x to the thirds, connected the x squareds, and connected the x's. And that is just fine. That's a lot of textbooks teach it that way. You drop the parentheses and combine the things with the like names, like terms. I think what most of you missed when you were doing that was the negatives. If you do that, make sure that the symbol in front goes with the number behind it. So that is a positive 3x squared, but that's a negative 1x squared, because a few of you put down 4x squared for that. I think a similar thing happened with the negative 12x and the positive 6x. You missed the negatives. Number 3. As a group, you did fairly well with number 3. There were a couple that again had problems with the negatives on this one. So 19y minus 3z plus 7y plus 12z. So I have the 19y. What can I combine that with? The 7y. Good. And that makes what? 19 and 7 give us 26y. Very good. Now I've got the negative 3z, and of course that can be combined with 12z to give us, I heard somebody mumble it back there, 9z. Now I have to have something to connect these. What am I going to put in between them? Addition. Good. It's a positive 9z, so I put an addition in there. Okay, so then number 4. This one I was mean enough to make you do subtraction. So we got 5x squared minus 19x plus 3. And we are subtracting 2x squared plus 15x minus 9. This is the one that was probably the most missed question on the quiz. So we're subtracting here. We got 3 minus a negative 9. And I always write it out. 3 minus a negative 9, which turns into 3 plus a positive 9. So 3 minus a negative 9 is, what does it become? Positive 12. Very good. Then we've got negative 19x minus 15x. So negative 19 minus 15. Negative 34. Very good. So negative 34x. Then 5x squared minus 2x squared. 3x squared. Wonderful. Now, 5 and 6 were just exercises in dealing with powers. When I multiply exponents that have the same base, remember an exponent, this whole thing is an exponent, and it has two parts. The base is the regular number that's being raised, and the power is the one that's in superscript like this, telling us how many of those bases we have multiplied together. So x to the 7th is literally 7 x's multiplied together. Now for numbers 5 here, we were given x to the 12th times x to the 9th. When we are multiplying exponents, with the same base, what do we do to the powers? You add powers. Very good. So this is going to be x to the 21, right? 12 plus 9 is 21. Now for number 6, we have x to the 8th divided by x to the 6th. When we divide exponents, so if we divide exponents with the same base, we do what to the powers? Subtract them when we divide. So when we're multiplying, you add them. When you're dividing, you subtract them. So this will be x to the 8 minus 6 would be 2. So x to the 2, x squared. Now number 7, we're going to combine a few things. So I want to show you a couple of things leading up to it. You know, if we have x to the 5th times x to the 11th, we're multiplying exponents with the same base. We're just going to add the powers. That is x to the 16th. If I put a coefficient or a number and a count in front of those names, like 6x to the 7th times 4x to the 13th, I still have to multiply the numbers because I'm multiplying. I multiply the counts. What is 6 times 4? Is 24. There we go. So we're still multiplying the numbers. We're multiplying the counts. But when we combine the names, we deal with the rules of exponents. X to the 7th times x to the 13th is x to the... We add the powers when we're multiplying those exponents. So 7 plus 13 is 20. So it's 24x to the 20. If I have more than one variable, I do each variable separately. Let's say I've got x to the 8th, y to the 11th, times x to the 5th, y to the 4th. I can do the x's first. X to the 8th times x to the 5th is going to give me x to the... I'm multiplying, which means I'm still adding powers.
X to the 13th.
13th, very good. 8 plus 5 is 13. Then I've got y to the 11th times y to the 4th.
Y to the 15th.
Wonderful. Y to the 15th. Very good. So now back to the problem on number 7 here. This is 8x to the 3rd y times 12 x squared y squared. So we start out by combining the counts. What is 8 times 12? 96. And then we do each name separately. X to the 3rd times x squared is x to the 5th. 3 plus 2 is 5. And then y times y squared is y to the 3rd. Good. You treat that as y to the 1, so 1 plus 2 is 3. So you get 96, x to the 5th, y to the 3rd. Any questions so far? Okay. So number 8. I'm going to look at one similar to number 8 quick first. So something like this, 5 times 3x minus 7. We're distributing here. We're just multiplying through. So the parentheses should always draw our attention. And we should always make sure to see if there's anything that needs to be done inside of those parentheses. 3x minus 7, there's nothing we can combine there. So there's nothing to do in those parentheses. These parentheses, however, are being multiplied by 5. So we have to multiply them by 5. 5 times 3x is 5 times 3x gives us 15x. And 5 times negative 7? Perfect, negative 35. So now for number 8 on the test, I combined that with a little bit of powers for our variables. So I have 4x times 12x plus 2y. So we're going to do the 4x times 12x. Gives us
48x squared.
Perfect, yes. 4 times 12 is 48. X times x is x squared. Then we've got 4x times 2y is 8xy. Good. And what do we link them together with? Plus. Right, yeah. 4 times 2 makes 8. X times y is xy. Any questions there? Okay. So now on number 9, we're going to multiply 2 of these 2-digit algebraic numbers, or 2 binomials we're going to multiply together. So here we have x plus 5 times 3x minus 2. Now we talked about FOIL, and we'll come back and look at FOIL in a little bit. But there's a more straightforward method, for me at least, is I'm just going to do 3x minus 2 times x plus 5. Doesn't really matter what order you put them in here. And I'm going to do long multiplication. 5 times negative 2 is negative 10. 5 times 3x is 15x. Good. So now we've multiplied every digit with the 5. We leave a blank here. We move over to the x. X times negative 2?
Negative 2x.
Negative 2x. And x times 3x is
3x squared.
3x squared. Now we just combine our pieces here. We got negative 10 and 0 is negative 10. 15x and negative 2x makes 15 and negative 2 would be 13x. Good. Now we just have the 3x squared. And that's it. Again, if you've seen FOIL and you prefer to do FOIL, the F stands for first. X times 3x is 3x squared. The O stands for outside. X times negative 2 is a negative 2x. The I stands for inside. 5 times 3x is 15x. And the L stands for last. 5 times negative 2 is a negative 10. And you would have to combine the x's in the middle there. So you got 3x squared. Negative 2 and 15 is a positive 13x minus 10. So you get the same answer either way. Any questions on that one? Okay, for number 10, there's a couple of things I want to do leading up to this one, just to kind of review. You know, as we saw up on number 6, if we have something like x to the 12th divided by x to the 4th, when we're dividing exponents that have the same base, we subtract the powers. So that would become x to the, what's 12 minus 4? 8. Very good. If I have more than one variable, like x to the 13th, y to the 5th, divided by x to the 10th, y, I can do each of them separately. So I'll do the x's first. X to the 13th divided by x to the 10th gives me x to the 3rd. Yes, 3 minus 10 is, or 13 minus 10 is 3. And then I've got y to the 5th divided by y is y to the 4th. Good. I treat this as y to the 1, so 5 minus 1 is 4. If I had a number on there with my variable, like 24 x to the 11th divided by 3 x to the 9th. I'm still dividing, so when I combine my counts, I still have to divide. 24 divided by 3 is 8. Very good. Then I do my rules with my powers on my variables. X to the 11th divided by x to the 9th is x to the 2. Very good. So now for number 10, we have 32x to the 4th times z to the 3rd over 8xz squared. So we're going to divide. 32 divided by 8 is 4. Good. Now we'll treat this as x to the 1. So x to the 4th divided by x is x to the 3rd. And z to the 3rd divided by z squared is just z. 3 minus 2 is 1. So that's z to the 1 or just z. So that was dividing with just single digits, monomials. For number 11, we're looking at multiple digits. If I have something like 24 x to the 8th, y to the 5th, minus 30 x to the 5th, y to the 6th. And I'm dividing by 6 x to the 4th, y to the 4th. This is basically like what I just did in number 10. I'm just treating it as two different problems. So my first problem is this one right here. 24 x to the 8th, y to the 5th, divided by 6 x to the 4th, y to the 4th. So what is 28 divided by 6? Or 24 divided by 6, I should say. So that's 4. X to the 8th divided by x to the 4th is x to the 4. Good. 8 minus 4 is 4. And y to the 5th divided by y to the 4th? Just y. So in the second part of the problem is we take the negative 30 x to the 5th, y to the 6th, divided by the 6, x to the 4th, y to the 4th. So what is negative 30 divided by 6? It's a negative, because negative divided by positive. 30 divided by 6 is negative 5. There we go. X to the 5th divided by x to the 4th. 5 minus 4 is 1, so yeah, that's just x. And y to the 6th divided by y to the 4th is y squared, y to the 2. So that's it. So now for number 11, we actually have 3 of those terms in there to divide out. We have 25x to the 3rd minus 15x squared plus 30x, and we're dividing by 5x. Makes more sense to me if I write it like this instead of with the parentheses and the division sign. So now I have 25x to the 3rd divided by 5x. So 25 divided by 5 is 5, and that'll be x. X squared, there we go. 3 minus 1 is 2. Next, then, we have the negative 15x squared divided by 5x. Negative 15 divided by 5 is negative 3. X squared divided by x. X, very good. And now we have the 30x divided by the 5x. 30 divided by 5? 6. Now it's positive, so I'm going to put a plus there to link it. And x divided by x cancels out. So there it is, 5x squared minus 3x plus 6. Now number 12 was kind of a trick question. 4 plus 2x. What can I do with that? That's the right answer. Absolutely nothing. When I'm adding, I must have the same name, and those do not have the same name. So I can't do anything with that. So it's either just 4 plus 2x or 2x plus 4 if you rearrange it. Either one is fine. So you should have corrections done on that quiz, so you can turn it back in and get your half points back on it. Next, we're going to look at quiz 8, which is 11-27. Get this one. So quiz 8, that's 11-27. We started out, we added a couple of extra operations in here. Instead of multiplying and dividing with our exponents, we threw in a power of an exponent. So if I have x to the 3rd to the power of 5, what did we do with those powers? This became x to the 15th. Very good. When we have a power of an exponent, we will multiply the powers. So it's just 3 times 5 gave us 15. So for number 1 there, we have x to the 4th to the power of 7. That's going to become what? X to the 28th. Good. 4 times 7 is 28. If I throw numbers in with that now, that was number 1, by the way. couple of things I can do to complicate this. Let's start out actually with doing multiple variables. Let's have x to the 9th, y to the 7th. I'll take this to the power of 11. Just like with multiplying or dividing, I can do each variable separately. So x to the 9th to the power of 11 is x to the 99, very good. And y to the 7th to the power of 11 is y to the 77. Good. Then if I have 5 x to the 12th to the power of 4, stick with me back there, guys. So when I've got a number in front of it like this, why don't you guys turn around and face the front of the room, guys? There we go. So when I have a number in front of it like this, we've got our coefficient, 5x to the 12th. We're going to take the count first. 5 to the power of 4, that's 5 to the 4th power, 5 times 5 times 5 times 5, which would be 625, very good. And then we deal with the variable. X to the 12th to the power of 4 is x to the... What's 12 times 4? 48, really good. So 625, x to the 48. So now on to what we actually did for number 2 then. Number 2 was 4 x squared y to the 8th z to the 5th to the power of 3. So there's 4 different pieces we have to do here. The first is the count, 4 to the power of 3, or 4 times 4 times 4 is what? 64, good. X squared to the power of 3 is x to the 6th, good. 2 times 3 is 6. Y to the 8th to the power of 3 is y to the 8 times 3 gives us 24, good. And z to the 5th to the power of 3 is z to the 15th, good. So number 2 is 64 x to the 6th, y to the 24th, z to the 15th. So now for number 3, for roots. Remember, the square root of 25 is asking us what number squared equals 25. So 25, the square root of 25 is 5 because 5 squared equals 25. So when we have a variable with a power on it that's square rooted, so the square root of x to the 18th, what power of x squared equals x to the 18th? Whatever's going to go in here would be multiplied by 2 to get 18. So we can work backwards. 18 divided by 2 would be 9. So when we do a square root, we're dividing the powers by 2. So the square root of x to the 18th is x to the 9. So then for number 4, if we have more than one variable in there, let's say I have x to the 20th, y to the 8th. Just like I did with powers, I take each piece individually. What's the square root of x to the 20th? What's 20 divided by 2? 10, good. X to the 10th. So then it's going to be y, the square root of y to the 8th will be y to the 4th. Good. 8 divided by 2 is 4. So the square root of x to the 20th, y to the 8th would be x to the 10th, y to the 4th. If I have a number on there, like the square root of 4, x to the 9th, x to the 16th, let's go. We still do this, the count, we still have to do the operation. What is the square root of 4? Square root of 4 is 2. And then we do the variable. What's the square root of x to the 16th? Careful. We divide the powers, get divided by 2. So it's x to the 8th. So if for the actual problem for number 4 is the square root of 16, x to the 12th, y to the 4th. So we actually have to do the square root of 16, which is 4. And then the square root of x to the 12th is x to the 6th. And the square root of y to the 4th is y to the 2, y squared. So that's it. It's right there if I get started. Okay, let's take a peek then at number 5. You can go in the next room, or you got a private room down there? Okay. Sounds good. We'll see you later. For number 5, if we have roots other than a square root, we have this little number here that indicates it. So this is indicating that this is a 4th root. If I have x to the 20, that other root here, this 4, just means I'm not dividing by 2, I'm dividing the power by 4. So that's going to be x to the 5th. Perfect. 20 divided by 4 is 5. So if I have the 5th root of x to the 35th, y to the 15th, I do each variable separately. What is the 5th root of x to the 35th? X to the 7. Very good. 35 divided by 5 is 7. How about the 5th root of y to the 15th? Y to the 3rd. Good. 15 divided by 5 is 3. Now when we put a number in front of it, we actually have to do the operation on the number. So a 3rd root, this is the actual number 5 here, of 8x to the 6th, y to the 15th. What is the 3rd root of 8? Well, what number to the 3rd power would equal 8? 2. Very good. Then the 3rd root of x to the 6th will be x to the 2. 6 divided by 3 is 2. And the 3rd root of y to the 15th will be y to the 5th. So 2x squared, y to the 5th. Number 6, we seem to struggle with. And it's just the distributing, I think, that got us. So I'm going to do a couple similar to number 6. And actually, this first one I'm going to do might actually be a little bit more difficult than number 6. So looking at a problem like this, we see parentheses. When we see parentheses, it always tells us to do something here first. And when there's more than one, we go left to right. So this is the first one we encounter. Now we always have to check, is there anything we can do inside this parentheses? And no, we cannot combine 7x minus 4y. So the second question then is there anything that needs to be done to the parentheses? That's going to be, in this case, it's going to be multiplied by the 5x. So we're going to distribute that. What is 5x times 7x? 35x squared. Very good. 5 times 7 is 35. X times x is x squared. Then we've got 5x times a negative 4y. Beautiful. Negative 20xy. 5 times negative 4 is negative 20. X times y is xy. Now this parentheses in this one is a little more difficult. There's nothing to do inside the parentheses. So we look to see if there's something that needs to be done to the parentheses. And it is being multiplied. But what's it being multiplied by? Perfect. Good job. It's a negative 2x, not just 2x. But that negative goes with the 2x. So now negative 2x times 3x is?
Negative 6x squared.
Perfect. Negative 6x squared. And negative 2x times 5? Negative 10x. Good. Now we've got the negative 3y here. So now we look for what we can combine. We've got 35x squared. Is there anything that can combine with that? Negative 6x squared. 35 and negative 6 make what? 29. And that stays x squared. Because now we're adding and subtracting, so we keep the same names. Is there anything we can combine with the negative 20xy? No. We have other x's and other y's, but they have to be both x and y to combine with that. So we don't have anything else. Nothing to combine with the negative 10x, and nothing to combine with the negative 3y. So that's it right there. That's as far as we can go. So now for the actual problem for number 6. We have 6a times 4a minus 2b plus 3b times 7a plus 4 minus 2b plus a squared. So again, this first parentheses, there's nothing for us to do. So we have to multiply it by the 6a. 6a times 4a gives us,
24a squared.
beautiful, 24a squared. 6a times negative 2b, negative 12ab, very good. Now the second set of parentheses, there's nothing to do inside them. So we're going to multiply by, that's a positive 3b. So 3b times 7a. 21ab. 3b times 4. 12b, good. Then we're subtracting 2b and adding a squared. What can we combine with the 24a squared? Just a squared. We treat that as a 1a squared. So 24 and 1 is 25a squared. The next room's available if you want to jump over there. So then we have negative 12ab, which is going to combine with 21ab. What's that make? Negative 12 and a positive 21. Positive 9ab. 12b and negative 2b make positive 10b plus 10b. Good job. So that is the algebra side of it. Anybody have any questions on that? Those top 6? Okay. Now we'll look at the bottom 4 here, which will kind of lead us into what we'll do after break. But scientific notation. And on the quizzes, I'm focused on scientific notation. A couple of you got some things messed up with engineering notation. Scientific notation there's only one digit before the decimal point. it cannot be a 0. So if I have 49 million, and I want to put that in scientific notation, my decimal point has to go right here. Only one digit in front of it. So that's 4.9. And remember, our power of 10 is going to be the same as the number of places my decimal point had to move. So it started out here, and it's going to here. So we're moving 1, 2, 3, 4, 5, 6, 7 places. So that's 10 to the 7th. Is it positive or negative? This is a big number, so these are the positive powered place values. So it is 10 to a positive 7. So now let's take a peek. If we want to look at number 7 here, 8.43 times 10 to the 5th. So that the 5, that power of 10, tells us how many places we have to move our decimal point. Now, it's positive, which means this is a big number. It's a large number. So we move our decimal point to make this number larger. 5 places. So we go 1, 2, then we have to start adding zeros. 3, 4, 5. So this would be 843,000. Number 8, 4.08 times 10 to the negative 3. Now again, that power of 3 is telling us we have to move the decimal point 3 spots. But the negative is telling us that this is a small number. So we have to move the decimal point 3 spots to make this smaller. So we go 1. Now we have to add zeros for 2 and 3. So that is 0.00408. Number 9, 0.00836. To put that in scientific notation, where does the decimal point have to go? Between what two digits? 8 and 3. So to get there, it has to move 1, 2, 3 spots. So this is 8.36 times 10 to the... Now we have to decide, is it a positive 3 or a negative 3? Negative 3. This is a small number, so that's a negative 3. And finally, for number 10, 9,010,000. Where does the decimal point need to go here? Between what two digits? The 9 and the 0 right there. So that becomes 9.01. The decimal point had to move 1, 2, 3, 4, 5, 6. Is that a positive 6 or a negative 6? Positive, because that's a large number. Okay, that concludes that quiz as well. So that one you should be ready to give back and send in for corrections. Let's take a 3-minute break. And we'll come back. Okay, so let's take a look and see how you did on these. Have you guys turn around and face up here for me? Not just your heads, your bodies too. There we go. Okay, so these first two, converting to scientific notation. 0.00087. Of course, that's going to be 8.7. The decimal point has to go after that first non-zero digit. Times 10 to what power? Just 5? Negative 5. This is a small number, so that's a negative power. Now this one, of course, the decimal point has to go there. This will be 5.9 times 10 to what power? 7. Positive or negative 7? Positive. Good. Yep, very good. It's positive. So now down here, this is 5.17 times 10 to the 6th. So that's 10 to the positive 6. Is that a big number or a small number? Does 10 to the positive 6 indicate a big number or a small number? Positive powers are big numbers. Good. There you go. So that means we've got to move our decimal point 6 spots to make this larger. So 1, 2, now we got to add zeros, 3, 4, 5, 6. So that is 5,170,000. Is that number in decimal notation? For those of you that were confused by that term decimal notation, that is just standard notation, standard numbers. So now for the 3.5 times 10 to the negative 6. 10 to the negative 6, is that going to make this a big number or a small number? Small, because the negative power. Good. To make it smaller, we move the decimal point to the left. So we go 1 spot, then we got to add zeros. 2, 3, 4, 5, 6. So that is 0.0000035. So that becomes. Now I will give you a fair warning. We're going to do about, 15, maybe 20 minutes of review here, and then you do have one more quiz to take. We do have a new quiz today. All the stuff that we just talked about with our variables would apply to any other number. If I had 8 to the power of 7 times 8 to the power of 3, because this is an exponent, because it has the same base, in this case the base is 8 instead of x or y, we could still do just 8 and then combine the powers. We're multiplying, so it would be 7 plus 3 is 10. Typically, though, we don't work with powers of 8 or anything else. What we work with is powers of 10. So let's say I have 10 to the 8th times 10 to the 4th. What's that going to become? That's going to become 10 to what power? To 12. Very good. 8 plus 4 will give us 12. Just like when we're multiplying variables, we add the powers. When we're multiplying numbers with those exponents, we add the powers. If I had 10 to the 6th divided by 10 to the 4th, what am I going to get? 10 to the 2nd. Very good. 6 minus 4 is 2. If I do a power of a power, 10 to the 4th to the power of 7, what am I going to get? 10 to the 28th. Very good. 4 times 7 is 28. Now I can get a little tricky. Let's say I have 10 to the 5th to the power of negative 4. A power of a power, I'm still going to multiply the powers. I get 10 to the negative 20. Good. I can have things like 10 to the 7th times 10 to the negative 9. I'm going to add the powers. It's going to give me 10 to the what? Negative 2. Good. 7 plus negative 9 is negative 2. If I'm dividing 10 to the 5th divided by 10 to the 12th, I'm still subtracting powers. I'm going to get 10 to the 5 minus 12 will be negative 7. Good. Or I might have 10 to the 4th divided by 10 to the negative 3rd. What's that going to give me? What's 4 minus negative 3? Positive 7. 10 to the 7th. So now then I can combine that into a couple of things. I can do like 10 to the third over 10 to the seventh to the power of negative 3. So I start out by combining what's inside the parentheses. What is 10 to the third divided by 10 to the seventh?
-4.
10 to the negative 4. Very good. 3 minus 7 is negative 4. Now I'm still taking that 10 to the negative 4 to the power of negative 3 is going to give me 10 to the
+12.
positive 12. Negative 4 times negative 3 is positive 12. Wonderful. Now I could get really ugly with it if I wanted to. I could do like 10 to the 5th divided by 10 to the negative 7th over 10 to the 3 times 10 to the negative 11th to the power of negative 5. Now in something like this looks really ugly, but it's really not as bad as it looks. We just have to take it step by step. So we got this enclosing symbol in the parentheses, so we have to work inside there. Inside the parentheses, we've got the fraction bar, which tells us we have to do what's on top of it first. So on top of the fraction bar, we've got 10 to the 5th divided by 10 to the negative 7. What is 5 minus a negative 7? That becomes the same as 5 plus 7, or 12. Very good. On bottom, we've got 10 to the third times 10 to the negative 11, which is 10 to the negative 8. Very good. 3 plus negative 11 is negative 8. So now this is all to the power of negative 5 yet. We still have to do this division. What is 10 to the 12th divided by 10 to the negative 8? 20. There we go. 12 minus the negative 8 is 12 plus 8, or 20. And that's still to the power of negative 5. So it's 10 to the 20 to the power of negative 5.
10 to the negative 100.
Perfect. 20 times negative 5 is negative 100. So 10 to the power of negative 100. Very good. Okay. So then we did talk last time about operations with scientific notation. Remember, when we add or subtract, we must have the same name. You're probably getting tired of hearing that phrase by now. You must have the same name for scientific notation that's the same power of 10. And then we keep the same name. So if I have 7.3 times 10 to the 12th plus 6.9 times 10 to the 12th. Do we have the same name? Yes, they're both 10 to the 12th. So now we're going to combine the counts. What's 7.3 plus 6.9? Good, 14.2 times 10 to the 12th. Can we leave it like that? Say no. No, because we have 2 digits in front of the decimal point. So we've got to move that decimal point over to make this 1.42. Now, did this number get smaller or bigger? It got smaller. It went from 14 to 1.4. So the number got smaller. The power gets bigger by 1. So 12 plus 1 is 13. So if we were going to do 8.7 times 10 to the negative 7th plus 7.8 times 10 to the negative 7th. We're going to combine the counts. What is 8.7 plus 7.8?
16.5.
16.5. Very good. Times 10 to the negative 7. We keep the same name. But again, we're going to have to move our decimal point, so this is going to become what?
1.65 times 10 to the negative 6.
Perfect. Yeah, this gets smaller, so this has to get bigger. Negative 7 plus 1 is negative 6. Very good. Subtraction is the same way. We might have 9.32 times 10 to the negative 12th minus 8.79 times 10 to the negative 12th. We have the same name. We have the same power of 10, so we subtract. 9.32 minus 8.79 is
0.53.
0.53 times 10 to the
Negative 12.
negative 12. We keep the same name. Now, of course, we see that this one has to change. What's this going to have to become?
0.53.
5.3. There we go. There's only zeros in front of the decimal point, so we got to move it over one to get a non-zero digit in front of the decimal point. Now, this time the number got bigger, so the power gets smaller. So negative 12 minus 1 is negative 13. Good. So if we try 7.23 times 10 to the 11th minus 6.59 times 10 to the 11th. 7.23 minus 6.59 is
0.73.
Careful. Something seems off there. I get 0.64. Is that right? 0.64? Okay.
Yeah.
Times 10. Oh, gotcha. So times 10 to the 11th. And that's going to get changed to be what?
6.4 times 10 to the...
Number got bigger. Power gets smaller. So 10. So now for multiplying or dividing, we do not need the same name. So we do not have to have the same power of 10. And then that we're also going to combine the names. So we also multiply the powers of 10, or the tens themselves to the power. So if we have 3.2 times 10 to the 8th times 5.1 times 10 to the 13th. We're going to combine the counts. 3.2 times 5.1 is
16.32.
16.32. Then we're also going to combine the names. So 10 to the 8th times 10 to the 13th is 10 to the... Remember, when we multiply, we add the powers. So 8 plus 13 gives us
21.
21. Good. And once again, we're not going to leave this as 13.32. It has to become what?
1.3. No, 1.6, because it should be 16.32.
Oh, thanks.
16.32.
Thank you. Sorry about that. 16.32, so 1.632. Nice catch. Times 10 to the number got smaller, so the power gets bigger. So 22. This went from 16 down to 1, so the power gets bigger by 1. So we might have 4.2 times 10 to the 7th times 7.5 times 10 to the 2nd. No problem. Where do we start, guys? 4.2 times 7.5, which is 31.5. Good. Times 10 to the... Perfect. Yeah, 10 to the 7th times 10 squared is 10 to the 9th. We're going to convert this to become what? 3.15 times 10 to the
10.
Perfect. The number got smaller, the power gets bigger by 1. So 9 plus 1 is 10. So then we can look at dividing. So 5.76 times 10 to the 3rd divided by 9.6 times 10 to the 9th. Just like with multiplying, we're going to combine the counts. 5.76 divided by 9.6 is 0.6. Very good. Times, we also combine the names. 10 to the 3rd divided by 10 to the 9th. Perfect. 3 minus 9 is negative 6. So now we have to move this decimal point to make this 6 times what? This number got larger, so the power has to get smaller this time. Negative 6 minus 1 is negative 7. So we might have 2.21 times 10 to the 8th divided by 2.6 times 10 to the 5th. We divide 2.21 divided by 2.6 gives us 0.85. Good. 10 to the 8th divided by 10 to the 5th. 10 to the positive 3. Good. 8 minus 5 is 3. And of course, we're going to rewrite that to be
8.5 10 to the 2nd.
Perfect. Yes. 10 to the 2. This number got larger, so the power gets smaller. 3 minus 1 is 2. We also looked at powers. We might have like a 5.1 times 10 to the negative 7th squared. Just like with our variables, we take the 5.1 squared, which is going to give us what? 26.01. And then we take our power of the power of 10. 10 to the negative 7th squared is 10 to the negative 7 times 2 is negative 14. And now just like before, we've got to adjust this. 2.601 times 10 to the... Careful. This got smaller, so the number gets bigger. Negative 14 plus 1. Because it's negative, it looks different. It goes to negative 13. So we might have 3.2 times 10 to the 6th. We'll square that one too. So we start out 3.2 squared is... What's 3.2 squared give us?
10.24.
10.24. Times 10 to the 6th squared is 10 to the 12. 6 times 2 is 12. And of course, this is going to get modified to be
1.024.
Yep. It's either 11 or 13. This number got smaller, so this gets larger. So that's 10 to the 13. And we had roots. I might do the third root of 1.728 times 10 to the 21. The third root of 1.728, if you're looking at a lot of your calculators, some of you actually have a third root key. Otherwise, you have to use an X root. You got to do 3, and then second, and most of you would be the caret key. Mine, it's in a math menu here. So I'm going to do 3, and then I hit my X root. Makes it look like that. So 1.728. I get 1.2. So the third root of 1.728 is 1.2. What's the third root of 10 to the 21st? You've got it. 7, yes. We take 21 divided by 3 is 7. 10 to the 7th. So if I have 6.76 times 10 to the 12th, I'm going to take the square root of that. What is the square root of 6.76?
1.8.
Oops, try that one again. Should be 2 point something. .6.
It's talking about the same as 1.8.
Now remember, you got to use just a square root this time. So it's to be second, then your x squared key.
Oh.
You're trying to do a third root again?
Yeah.
Okay, that'll do it.
Yep.
2.6. Good. And then the square root of 10 to the 12th is 10 to the 6th. We divide the power by 2 when we square root. Okay. Well, with that, I think you guys are ready for the quiz. So I'll let you guys have the last 15 minutes here to do the quiz. It'll be a week till I see you again. We're going to pick up with solving equations and doing more problem solving, which is something that I know groups struggle with problem solving, picking information out of a problem. So these last 12 weeks of the semester here, you guys are really going to have to let me know when you're confused, because everybody gets confused when we start solving problems and picking information out of word problems. So please speak up and let me know when we need to go over stuff again. So I'll let you guys get started on the quiz. You can have the last 15 minutes to work on the quiz. There is no new homework tonight.